Hello folks, it's me again, and we'll be looking at Factorising 3. Now Easter is done. I promise you won't always just look at algebra, we are getting towards the end of it, but just to refresh what we were doing on Factorising. So the Factorising, the whole point was looking at an algebraic expression and trying to find something basically that was in common from all the different pieces and sort of take it out. So the idea you would say is, if you were looking at an example, what do 6 and 15 have in common? You'd be, oh, they're both in the 3 times table. That's the principle of factorising, okay? So if we look at this, for example here, 5a squared adds 7a cubed. Whoopie-doo, that looks nice. Not really. That's my email blinging on my laptop. Anyway, get back to this. We've got two pieces basically, and they're not like terms. We can't simplify it because a squareds aren't the same as a cubed. So we can't make that any simpler, but we can factorise, and that's because they share something in common. What we normally do is we look at the numbers for a start, so 5 and 7, and we'd say, a bit like I did at the start, do 5 and 7 have anything in common? No, they don't, do they? Basically nothing goes into both of them apart from 1, and we don't count that. So let's look at the algebraic bit then. A squared and a cubed. And you'd be like, well, okay, both basically algebra bits, they're like A's. And you go, okay, well, they both contain an A, all right, which is true. A goes into a squared and A goes into a cubed. This one will be a bit harder though, because actually there is more than that. If you think what A squared means, it means A times A. And A cubed means A times A times A. So actually, they don't just share an A, they share a couple of A's, or an A squared. So there's an a squared in that one, and there's an a squared one in this one. If you think about it, a squared times a gives you a cubed. So in this case, you would take out the a squared, and you would say to yourself, well, how many a squareds make 5a squared? Or what do I times a squared by to get to 5a squared? Well, just the bit at the front, 5. So you put your arrow there if you want, and that's it. What do we times a squared by to get to the 7a cubed? Well, the outside bit's the easy bit, the 7, we can see that. But what about the rest of it? Because if we just times a squared by 7, we'll get 7a squared. So it's that idea, we need to times it by 7a, because a squared times a gives me a cubed. And so now, put the sign back the same as it was previously, and that would be your factorised version. It's not a simplified version, it's just like, factorised version, just a different way of expressing it, okay? What we essentially say is you're expressing it as a product, something times something else, rather than a sum or a difference. So this one, again, I've got a sum, a cubes and a to the power of 5s. The different terms, they don't like terms, and so we can't simplify it in that way. What we can do, though, is say, what do they both share? So, start with the numbers, 4 and 10. What number goes into 4 and 10? Or what do they have in common? Well, in this case, we'd be saying, well, they're both even. So, they're both in the 2 times table. So, we'll take the 2 out for a start, okay? Then we'll look at the algebraic bits, a cubed and a to the power of 5. Well, that's got a times a times a, and this is, I'm going to run out of time saying it, but a times a times a times a times a, or a to the power of 5. So they share like 3 a's really. They both got a's in them. That one's got 3 a's all times together, that's got 5 of them. So we can take out the a cubed, and then we can say, okay, what do I times it by then to get to the first bit? So 2a cubed times what gives me 4a cubed? Well, you've got the a cubed match, that's all right, so just the numbers. 2 times what gives you 4? 2. And then we'll do the second one here. What do we times 2 by to get to 10? You're shouting 5, and so we'll put the 5 down. And a cubed times what gives me a to the power of 5? If we think back to our indices, a cubed times a squared gives me a to the power of 5. Remember, 3 and 2 is 5. That was me whispering, okay? And then we'll just put the sign back in the middle, the plus, and we're done. Okay, so this one, again, we haven't got the powers, but we've got lots of different letters, which is nice. 5CD, add 3CD, okay? Well, this one is literally a bit of a trick question because the idea is you'd say, well, hold on a second, like terms, hold on, like terms, CD, CD, I could just match them together. So this one here, we haven't got any factorising, okay? We don't need to worry about it. I'll tell you why. Because 5 somethings, add 3 somethings, gives you 8 somethings. And so that one there, because you've got like terms, we're not going to necessarily go, okay, we'll take it out, all right, okay? We would simplify at the start. If you hadn't spotted that and you were going to do it, you'd be go, oh, okay, they share a CD. How many are there in the first one? 5. How many are there in the second one? 3. And of course, what happens now? 5 add 3 is 8. because you can actually simplify that bit in the brackets. So you get CD times 8, which of course would end up with that. But I would never write that down. You just would literally think, always think simplify first, okay? This one, again, 15AB and 12BA. I'm really not thinking factorise because we should remember AB and BA are the same. Okay, so I said to you before, if we write the second one, we're always going alphabetical order. 15AB had 12AB. We're now thinking, okay, I don't need to be taking out the ABs from it, or what do 15 and 12 share in common? We'll just simplify it. So 15 and 12 is 27, so we've got 27AB. And that is, again, I know you're going to say, sir, you're being silly here by saying, you know, factorise and not. But I think it's important, we just get in the habit of thinking factorise when you can't simplify, and if you can simplify, do simplify. Okay, this last one here, we've got ABC at ABD. This one, you are going to have to factorise. I'll tell you why, because ABC has things in common with ABD, but it's not the same. That's got a C, that's got a D. So in this case, we can't simplify it, we can't group like terms. But what we can do is say, what do they share in common? So this one's got an A and a B in it, and that one's got an A and a B in it. So that would be the common part. And so the idea is we would take the AB out, open the brackets. What do I times AB by to get to ABC? Well, just the C. And what do I times AB by to get to ABD? Just the D. And so put the plus in the middle. And that's quite clever, really. So those two things are equivalent. And of course, don't forget, you can check by multiplying out the brackets. And the last one, A squared B had B squared A. It's tempting to want to rewrite this one. I like the alphabetical order. So if I just do that, A squared B add AB squared, you might think they're like terms. They're not quite, okay? That one's got A times A, and that's just got A on its own. That's just got B on its own, and that's got B times B. So in this one, commonality though, you'd pretty spot it at the start, they're A's and B's. They both have an A, they both have a B in it, okay? So what we can do is take out an AB from both. What do I times AB by to get to A squared B? Well, I've got the B. I just need to times the A by another A, or times by itself to get to the A squared. That will give you this. And what do I times AB by to get to AB squared? Well, I've got the A, but I need to times the B by something to make the B squared. And so that will be B. And of course, put the sign the same in the middle. And again, that would be the factorised version of this. Again, these are probably as hard as you'd need to go, all right? Certainly at the moment. Anyway, hope that's helped, all right? I'll scan this, get it on the share drive, and I'll see you next lesson, all right? Take care of yourselves, all right? Stay safe, be healthy. Bye-bye.